In this video, I want to talk about building reproducible machine learning pipelines and why that matters. The deployment of a machine learning model is the process of making our model available in production environments where they can provide predictions to other software systems. When we develop our machine learning models, we do so in the so-called research environment. This is an isolated environment without contact to live data, where the data scientist has the freedom to try and research the different models and find out a solution to a certain product need. In a common setting, we have historical data, and we use this data to train a machine learning model. Once we are happy with the performance of our model in the research environment, we are ready to migrate it to the production environment, where it can receive input from live data and output predictions that can be used to make decisions. We often talk about deployment of machine learning models when in fact we mean deployment of a machine learning pipeline. So what is a machine learning pipeline? It is the series of steps that need to occur from the moment we received the data to the moment we obtain a prediction. A typical machine learning pipeline includes a big proportion of feature transformation steps. Perhaps this is even the biggest part of the pipeline. Then it includes steps to train the machine learning model and steps to output a prediction. We create an entire pipeline in a research environment, and we need to deploy as well the entire pipeline to the production environment. Why do we need to do so? Well, because in the live environment, we're also going to receive raw data as input, and we need to transform it to create the necessary features so that the model can interpret them and return the prediction. When we deploy our pipeline to production, we need to do it in a way so that the pipelines are reproducible. What does this mean? It means that if both the pipeline in the research environment and the pipeline in the production environment receive the same raw data as input, both pipelines should return the same prediction. Same data comes in, same outputs should come out of both pipelines. Why? During the research phase of our project, we build a model and we optimize its performance so that it maximizes the business value. When we develop a machine learning model, or a machine learning pipeline I should say, we test model performance from a statistical perspective, utilizing classical metrics like the accuracy, the precision, recall, median square error, and any other metric that you're familiar with. And we also evaluate metrics that translate these parameters into business value. For example, we may measure the increased revenue that our model will create, or the increased customer satisfaction, or any other measure that we're interested in and that will vary with the organization. If we want to translate this value, this revenue increase, for example, as I show in this slide, from our research environment to the real life, that is, to the live environment, we need to make sure that the live model reproduces exactly, or at least as much as possible in practice, the model we created in the research environment. This is why our models need to be reproducible. So why reproducibility matters? First, if we cannot reproduce our machine learning pipelines within the research and production environments, we may incur in financial costs, as I discussed in the previous slide, but we also incur in substantial time loss because we need to spend a lot of time trying to dig out why the models are not identical, or at least very similar. And this will end up in the loss of reputation of the team. But more important, for me at least, is the fact that without the ability to replicate the model's results exactly, it is very difficult to determine if a new model is truly better than the existing one. When we develop a machine learning model, we usually compare it with the current model or set of rules that the organization is using. Without the ability to replicate the results exactly, it is very difficult to determine if the new model is truly better than the current one.